So for our final speaker in the Queen Charlotte room today, we've got George Wilson to take us through the story of Paddle's in-house microservice toolkit. So like so many of us, George is a fellow Raspberry Pi enthusiast. He was formerly the engineering manager at Cover and the CTO at Car Throttle, and he's presently the engineering manager for payments at Paddle. So Alex Salmon, one of George's colleagues, was due to be here a little bit later on to do some Q&A stuff for us, but he's not been able to attend, but we'll keep George company, won't we, team? Yeah. And some of the questions George might be able to answer himself. We'll see what happens. But with that, take it away. George Wilson, everyone.
Thank you. Thanks for coming, everyone. It's really fun to be here, and I've spoken to so many people already. Yeah, it's a great event, and thanks for having us. Good grapefruit juice as well. So we're going to talk about, very briefly, like what Paddle is, in case you haven't heard of us, and how we build things today. And then I'll talk about the journey to how we got to that point of how we build things today, because it's kind of an interesting story, and it involved lots of cultural change and lots of interesting engineering problems as well. I'll reflect on that and just tell you about how we think it went and some of the benefits, some of the challenges, and then we'll do a brief Q&A. But yeah, sadly, Alex not with us to dive into the super technical stuff. But maybe afterwards, some of the engineers are around, so you can come to here or the booth outside, and we'll do our best. Cool. So Paddle is a developer-first platform for selling digital products, which means basically developers trust us to sell their products for them, so they don't have to deal with a bunch of complexity around selling things in all the countries around the world. This is sometimes called merchant of record. It basically means we file the taxes for you, because filing taxes is a nightmare. So we do things like checkout conversion, payment acceptance, subscription billing, invoicing, retention for SaaS companies, and that sort of stuff through like an API-first model. There's a few different products in our suite. Today we're just going to be talking about billing, which is the sort of historic Paddle product, and that's where all of our Go stack is. Some of these other products are really interesting. They came through acquisition. They use a Python stack, which is interesting, but not for this conference, obviously. These will give you some sort of numbers to kind of show you what scale we're at. We're not massive, but we've been around since 2012. But had most of our growth in the last few years, and we're getting to the sort of scale and size now in terms of actual transaction volume, but also the number of teams and engineers working on our system, where we've got some interesting challenges. We're the market leader for merchant of record in digital goods space. So we've got a fairly complex system at this point, and some legacy, scary stuff. But we enjoy a challenge. About 90 people in engineering now. We have some PHP, we have some Go, and a bit of Python that I've talked about. Front-end stuff, mostly React. We have 9 product teams. Each of those own their own product domain, product area. My team work on payment stuff, but we have quite a few different things with different target audiences. And they own like a collection of services and components. The other teams are enabler teams. So we have a platform group where we have an AppEx team, which is what I'm going to talk about today. And they work on the kind of shared libraries, how services communicate, and that's what we're going to talk about. We also have SRE, working on reining in the infrastructure complexity, cost, reliability practices, security, data engineering, stuff like that. So here's how we build systems today. We have like a not so microservice architecture. We like the fact that services that are separate our domains and giving teams ownership. We're not going to talk about too much why microservices. I'm sure you've heard of all of that before. But it's about how we approach building our services. We have these top-down standards. And this is the kind of theme of the talk, of this conflict between like having standards but not slowing teams down too much. We have these because we want to rein in that complexity. We want to try and encourage maintainability. But as I said, they can slow you down. So what we also have is this bottom-up approach where we provide teams with building blocks. And we say, like, this is the easiest way to just conform to those standards. And if you follow it, you don't have to, but you'll probably find that systems are easier to maintain and complexity is reined in. And this is what we're going to talk about today. Here is like a visualization. Can you see that at the back? No, I'm kidding. Obviously, you can't It's getting really big. It's not crazy. So on here, I think the green ones are services, and the pink ones are like mostly libraries. I think the blue ones are kind of like standalone applications that we have multiple instances of. This is a really cool custom tool which we use to figure out like which teams are using which library and which systems need updating when we have a dependency. We want to open source this. Alec made this. He was going to talk about it. So we'll do a follow-up talk about that some other time. We have this vision that building services should be boring, right? We don't want to show off about how many services we have, but we want teams to focus on their product area and spend their engineering resources on solving problems for our customers, building new value, right? Some systems require unique technology. I'm not saying you've got to use Postgres everywhere. I'm just saying most of the time you should probably use Postgres everywhere, right? So, when we do create these new services, what we want to do is just make sure that we have this maintainable system and as reliable as possible. And we think the way to do that is to make them really consistent. We want to reduce the amount of energy engineers spend solving problems that aren't unique to them. So, one of the promises of services, though, is that teams should be independent, use the right tool for the job, right? It's this powerful thing that I can go off and make my own choices, make my own decisions. But there's some danger to that, right? I'm going to talk a little bit about why we think that's dangerous, some of the disadvantages we have. But right now, this is our view, right? Consistency is a catalyst that really, really helps our team. It wasn't always this way. So around 2020, our strategy was actually have as much independence as possible, right? So basically the polar opposite. We were scared to have central decision-making because we didn't want to slow teams down. To be fair, we got burnt by having like a very big, complex monolith. I think it was a reaction to that. So what happened was we had services. We have this explosion in the tech stack. We've got ECS and Fargate going on. We've got Lambdas. We've got like Elastic Beanstalk systems, Heroku. Everyone deploys in their own way, like no shared workflow. It's just this crazy rush to like build as much as we can, as quick as possible. It doesn't matter how. Even within the Go systems, we've got like REST, we've got gRPC, we've got like totally different API designs going on, and the internal layout of them was like totally different. You couldn't jump onto between projects and have the same experience. 3 different ways, maybe more, to like just validate request bodies and that sort of thing. But that we celebrated, right? Like, we thought that the lack of red tape when you're adopting a new technology is an advantage. But as you can probably imagine, and you may have experienced this, problems start to emerge. We have lots of debates. Teams would be discussing, like, which library should we use for validation on our new service? How should we consume messages from this queue? How do we inject database connection pools and that sort of thing? So, this really is not what we want people to be focusing on in our product teams. We ended up with kind of like, maybe in some cases 1 person who knew how that system worked, maybe 2, maybe 3, right? So you have this bus factor that scares you, where like some systems, only 1 person knows how they built it and why they chose that library in particular. And it became very, very difficult as we grew around that time, 2020, 2021, to like onboard new engineers and explain how to be productive and what we use. It's just very, very costly to maintain a system with a really diverse tech stack. That maintenance cost really starts holding you back once it's been there for a few years, so you don't really see it at first. And it's really hard to invest in that platform and solve those problems if there's few common components. So like migrating a system to use like a new approach for something is kind of infeasible just because there's so many different things you have to rebuild. For Paddle, it was like an investment in reliability. But there are other reasons as well. And like, don't underestimate familiarity for engineers and what an advantage that can be, right? So if a system's not under active development, it kind of rots. It's very difficult to go back to that system and remember like how that workflow works. We have examples that we built some systems on Lambdas that we have a couple of them still today. And that's a great way to build systems for a load of use cases. But because it wasn't the main way we did it, the workflow didn't get maintained, and it's not in developers' minds how to be productive on that system. So it's really, really difficult, and it really starts slowing you down. And this manifests itself externally as well. So our APIs weren't easy to use. We didn't have a great developer experience. Some of our products didn't feel like one suite. We had an invoicing tool that had a different customer database to the subscription tool, which was really, really difficult. And it kind of came from this fact that teams were working on their own systems in their own way. And then finally, we also have a couple of reliability problems, which is, there's lots of reasons you have reliability issues, lots of ways you can solve that. But the fact that we couldn't invest centrally and really help all these teams solve those reliability problems was really difficult. So we started converging. We said, right, this has got to end. But how do we do this? The first things to be consolidated was infrastructure. There was a kind of line drawn to basically create a central team for SRE and reliability practices. But those teams building services, they were left to be independent. Really, the culture wasn't there to start telling teams how they should be implementing applications. So we said, right, you've got to be writing Go or PHP services. They've got to be hosted on ECS. We're using this workflow. We're just going to use Postgres most of the time, unless there's a very good reason not to. We started to unify all the build systems, the deployment tooling to one platform so that developers knew how to deploy on different systems. They only had to learn one system. But this consistent approach to actually writing Go code, building the services, was still very alien to our culture. We didn't want to upset people. We were scared of upsetting engineers. And the idea of having kind of a central team to address some of those things was in conflict. I think there were a lot of people who wanted that, a lot of people who didn't. Right? There's that core conflict between, having central decisions. Does it help you or does it hinder you? We didn't want to have gatekeepers, though. We all agreed on that. The big architectural decisions we needed to make for the product should still be owned by those product teams. But the big change happened in 2021. We started a new team, and we decided to invest in this. And that was mainly made through some big hires, principal engineer Alec, who's not with us. This is not a stock photo. That's actually Alec, and that's actually Dan. Dan's over there. And we created this team that today we call AppEx, application experience. Some people might call it a platform team or a core team. It doesn't really matter. And we created this vision for really we need to get to consistency. We had this belief that many of the problems teams are working on are not delivering much product value. They're the same across those teams. And this long-term vision that actually someday we would get to a place where you're kind of using the same framework for most of the things, apart from the stuff that's unique to your product domain. But we didn't share that. There was a kind of strategy call on how do we get there. And the idea was we would, instead of saying top-down, you must do it this way, we would change the culture by creating a bottom-up approach, this golden path. If we make it very, very easy for our services to conform to those standards, by providing libraries and frameworks and templates and things like that, we might find that teams kind of choose just because it's easiest, and the outcome will be consistency, and the outcome will be a really maintainable system that we're really productive with. So there are a couple of other things that made us make this decision. We rebuilt a ton of stuff in our product. It was a hugely ambitious product that we needed to fix this cohesion. We needed to be developer first. We needed to have a great API. We were ready to massively invest to go back to the market and really solve bigger problems for bigger customers. We knew that to do that, we would have to have multiple teams all working together to create this cohesion. We couldn't be independent anymore. And we had to kind of dog food our API. We had to get in the mindset that everyone's contributing to this API that people outside of Paddle, our customers, those are developers, they want to use. So we did that by starting a DX team, but we also tried to get everyone to adopt the same API specs in all of their services that were the same externally. And that, API specs are a top-down thing. It's saying you have to conform to this, right? So we needed to, create easy ways for them, for the teams to achieve that. So this is how it started. I'm going to dive into some examples of what we built. So the first problem we started thinking about was, how does authorization work? How does authentication work across these new systems, but also across our legacy stuff? This was a natural fit for what the AppEx team were there for. You've got a principal engineer. They're going to figure out how we're going to solve this problem. It was a bit of a distraction from this vision of making the teams all work really consistently. But actually, there was this silver lining to that stuff. Because all of the new systems would have to implement auth somehow or another. They would also have to sit behind this sort of API gateway idea that we chose. Not going to talk about that, different talk. And so actually, it gave us a starting point for creating lots and lots of these shared libraries. And it was a bit of a trial run for how to engage with teams and get them to use these elements of the toolkit. So we're going to talk through a couple of these things with a few code examples. So this is a library that enables developers to implement permission checks. It's kind of like a DSL. It uses generics, so you basically provide it an entity, and you can implement a method on it that can check various properties about that entity against a scope. So we create two libraries, one called GoScope, which defines the format of scopes, which is basically this subject can do these actions on this entity. And GoAuth, which provides our authentication middleware and our authorization sort of DSL, which is really, really cool. And this is an example of one of these hard problems that we kind of had to solve centrally. Another one is pagination. Teams love to debate pagination, right? So cursor-based pagination is the way we chose. We wanted to standardize all the services using the same request responses, do everything in the same way. There's this obvious overlap, all the teams had to implement this. Since they were all using Postgres, we knew they were building their queries in the same way. So this made sense, actually, as the first kind of boilerplate that we were starting to replace from those teams. So this is the server-side part, where you basically pass the request parameters and send them to a query builder ready to go, and you standardize the response that you're giving back. And then on the client-side part of the library, you've got this iterator that you can range through to make it really, really simple to get the total or go through each page. It's a fairly simple idea, but it was the sort of start of the toolkit. So this warmed people up. Owning something complicated and that was an integration point between the teams, between the systems, convinced them that this is good. This isn't, we're not distracting you from your product. We're solving these problems. At this point, we're still just building piecemeal libraries, but we started to look at other places first to see if we could build on this. Here are some of the original ones that we built. Most of them are still used today. We focused on boilerplate, right? That I'm hoping that most of you have experience in seeing different solutions for these problems. You're familiar with them. And these were kind of focused on making it quickly to build services, build these new products that we were trying to get out the door. Go handler is a really cool one. So this allows engineers to implement very, very simple Go functions that we then wrap into a HTTP handler function. So you define your request and response structs, and you just have a function where your business logic goes, right? That's the idea. We lean on open source a lot, by the way. We're not inventing all of this from scratch. So HTTP in is the library that can take those struct tags and give us the logic there, which is really awesome. And some of the magic here is that it can interpret the response. So if you return nil, we return the correct 204 status code for our API. And if you return errors, we have a standardized error response, which you get in the response body. And this is huge, and it kind of sounds silly now, but a lot of teams were writing their own JSON marshalling, copying, pasting between handlers. Some of them were new to Go. Not everyone knew best practices. There was different libraries. So this really, really helped just say, look, when you're implementing a server, you can kind of just do it like this, and you don't have to worry about meeting the API spec that we're shipping to customers. Another great example of where we think these common problems are is service-to-service communication. So this covers both synchronous API calls and asynchronous communication. So our AppEx team defined this architectural pattern for event publishing and subscribing. Again, that's probably a whole talk in itself about how we decided to do that. But we really, really needed strict schemas, strict versions on events, and to be using the same systems that gave us that reliability that we needed. I've got some examples in a minute for these. The other ones are like other generic boilerplate, right? So not all teams adopted these because if they built their service earlier, they might have already had their same solution. So one of the challenges we had is that like we had to go back and try and convince teams to like swap this in and out. But for pretty much everything we built after mid-2022, we were now using these libraries. Go BDD is an interesting one. We really like integration tests that run on our service and test the service as kind of like a black box. We lean on Godog to do a lot of this, but basically we want to run the actual service. We like mocking things with Go. We really enjoy using Go for all of that stuff. The fact that we use BDD and the Gherkin syntax is kind of like, people might have opinions on that. For us, it works really well. And being able to just say to teams like, just drop your service in here and start writing API-level tests really helped improve the quality and the consistency of everyone's tests. Go validator is a cool one. So we decided to use JSON schema, if people know that, which is a standard way of defining validation rules for JSON payloads. We preferred this to using Go because this sits in front of struct validation. Like some services need struct validation as well, but validating it before that, we really like. We can also, there seems to be a unification of JSON schema with OpenAPI. I don't think we have it at the moment. What we want to do is generate our JSON schemas from our API specs automatically, which is something we do today for error responses. So we have like an automated system which will define all the errors from the API specs as Go values. And when you import that library, you can return them, and you know they're the ones in the spec. We're not quite there with the JSON schemas, but this is where we want to go in. So the process payment event JSON schema would come from the API specs repo. That's the idea. So this just creates a middleware from those files ready to go that you can just drop in. So the early feedback as we got into 2023 was that people liked it. It was going well, right? These were high-quality libraries. We'd really thought through how they would work best, and they were enabling us to ship the product. Dependency management was slightly difficult. We had to chase a few people to make sure they were like using them and taking the updates, because in the early days, you iterate a lot to choose, like, just to figure out what the right abstraction level is and how much should the library do versus the service, that sort of thing. But services are still very different. These are just libraries. This is not really solving the main problem. So what we did then was come up with a service template. We said, look, things are going to work together like this. And by that point, the appetite for that was there, right? People wanted to use the libraries. We saw that, and then it's like, okay, right now, we can just take it off a plate. So we use the GitHub repo templates feature. It's quite basic, but it works quite well. We give teams this ready for production, very well tested example HTTP service. So it has like working endpoints. You can hit the service, you can see it working, you can run those tests. It just puts the libraries in the right places, and it gives you a project structure, some of the handlers we've got in there, and it from the beginning, it gave people example BDD tests, which they could just then go and use. So we used this of kind of shoehorning more best practices in to drive more consistency. And the adoption was really good. As soon as we shipped this, pretty much, I think every new service we've had uses it. Here's the folder structure. I don't think the Go community has a defined what a Go project should look like, for better or worse. But this is what ours looks like. The slides will be available afterwards. We have things like we export a client package, make sure that's exposed to everyone. That's kind of interesting part of it. We have the types as well. So like user.go has the types that the other services that use this service can use, for example. We have a standardized way of defining database migrations that are in there as well. Other than that, it's a pretty straightforward service template that you should recognize. There's a bit of a case study here. My team, we're new to it. We were actually working on payment stuff in gRPC land. There's probably people here who use gRPC. We needed to get some stuff done for the big new project that we're trying to ship, but we were kind of alien to it. We weren't part of these discussions about what the new APIs were going to look like, whether we were using REST. And so we said, look, this is not our core competency. We're used to gRPC. How can we move as fast as possible and just know that it's going to work, and we don't have to think about it too much? So we said, give us everything. Like, just give us everything you have. And we used the service template. We used as many libraries as possible. And it was a good test to see how much we could offload to this AppEx team and this new way of working. And it was kind of nerve-wracking doing this brand new service. And I wasn't sure how the engineers would take it, given that they're really bought into gRPC. And it was pretty shocking, because it was kind of overwhelmingly positive. And gRPC does a lot of things really, really well. And I'm not trying to say that it doesn't. I'm not trying to convince you not to. But what we had was like underinvestment in our gRPC toolkit and workflow because we had that much diversity. And what we found was that now we've got a team building and saying, like, we've got all of these things ready to go. Actually, we were beating it, and this was a more desirable experience. Engineers were seeing the productivity, seeing the quality level go. And I got a couple of questions basically saying, can we migrate everything to this? Let's go. We didn't do that. But maybe one day, because we do believe that that is the way forward. gRPC does some things a lot better than our toolkits, but the consistency is more valuable for us. A few more things to dive into. So feature flags, testing, observability tools. These are more really common problems that you guys should think about and probably try and standardize. With feature flags, it's really important that you, firstly, probably don't tie yourself to one provider if you use LaunchDarkly like us, but also that you're calling it with the exact same inputs. So we had problems where we thought we were sending it the same parameters. So you have one rule that two different systems are evaluating. So it's really important you standardize that stuff. And a few more things for testing to help our BDD land and standardize that further, including a very, very cool library called Go Testament, which will spin up Postgres inside Go without having to worry about Docker. It's very cool. That's something we should ask Alec about and do another conference talk on. So the lots of small libraries approach really worked well. We had this convergence of how people were building services that people were giving really good feedback on. But then it was really time to say, you're all using these things together. Let's merge them. Let's finally move to this framework. We had this appetite because the AppEx team had proved that it was better to move the undifferentiated parts of all these services to one place. We didn't build a full-on framework, right? So we want to leave it to teams to bring and choose their own elements from the toolkit still. But we basically simplified and moved more and more of the boilerplate away. So we created Go HTTP server, which is a very standardized way that we define all of our services. And the real amazing benefit here is recently we rolled out OpenTelemetry and invested a lot into observability. And it would be pretty inconceivable to be able to achieve that migration in the time that we did it in, which was a couple of weeks, if all the services had wildly different approaches. Even though you can have middleware functions, Go has a really great standard library for that. This really made it very, very, very straightforward. That central investment starts paying off. Build pipelines. So we decided to have a declarative approach to build pipelines to standardize this. We're not quite there yet with all of this, but basically standardizing our base image for our Docker builds, standardizing our linting rules, allowed teams to take things off the shelf and add in coverage checks and custom checks that work really well for us. We have quite a cool system which will look at the GitHub repo tags and then infer which pipeline needs to be used and in what configuration, which is really fun. And that gives teams a starting point. For most new services, we don't really edit that. We just go, you're ready for production, and then as your needs change, you can then customize it a bit. And it was this bottom-up approach for building out this toolkit that, it drove consistency across our stack. But actually what it did was change our culture in the engineering org to be accepting of that consistency, and it's become one of our core values now. And we did that because we gained the trust of the teams. Letting teams choose these elements was really powerful because it puts aside that worry that you've got this architecture team gatekeeping, right? But that team have to really listen. They have to adjust based on feedback, and truly believe that role as an enabler, right? To work on enabling those other teams, not making all of their decisions for them. It's become such a value now that we kind of have an explicit goal of conformance. It was really clear to our teams that adoption was now beneficial. Enough of our toolkit was in use. It's not in use everywhere yet, but we're all leveraging that consistency now. So we wanted to have a mechanism to kind of measure the adoption of this and to try and encourage people to invest a little bit more time in getting there. So we use a tool called Rody, which is an open source project called Backstage, but like a hosted version of it, which is really fun. And you can make things called scorecards for your services. So we wrote a scorecard which measures like how many elements of the toolkit are in use versus bespoke things. And this is really powerful because it lets us know, oh, they're not using it. Maybe they would benefit from it. And when you're rolling out things like OpenTelemetry across all of your services, you can very quickly see which services are using it versus aren't and make that happen. Here's another screenshot of some of the other scorecards we have that measures everything across all services with made-up numbers, just in case like our security was like 1 and then you started to have a look around. So that's a kind of cool tool that you guys can take a look at afterwards. The job of creating consistency and building out the toolkit is probably never over, right? We'll probably revisit some of the problems we've already solved. And there are going to be more things to standardize as more things become common and we discover those as well. Here are some of the things we're looking at next. There's some really interesting talks that cover this stuff, which we've been learning from, which is great. So how did it go, right? So we think this was a really good idea because we saw teams choose consistency, which is kind of a unique way of doing it. We didn't ask for them to follow this, but teams basically wanted this, which we think is evidence that they saw the productivity benefits. We got Paddle billing launched, and we're really, really proud of it. We've had really great feedback about our developer experience, our new developer tools, and the new sort of ecosystem in the product with all of its concepts. The time we take building new systems is down a bit, but actually it's the time taken to get them production ready that's massively improved. It used to be a very daunting experience launching a new service, and it's not quite so daunting anymore. We think we're writing better quality code and creating better quality systems because our tests are better. The service-to-service integration patterns are more powerful. And like we're just getting better feedback from engineers, right? We want to listen from engineers and go, how productive are you feeling? What annoys you? And we're deploying very frequently. Those engineering debates where we would endlessly argue about how to validate stuff kind of went away. We still have debates, don't worry, but they tend to be about new problems and problems in the product, which is where we want it. We have fewer product initiatives that are like blocked in those early stages where we have to decide what library to use and how our service should look. And we're not blocked as much anymore in the late stages when we're not production ready and we need to get our act together. Now we're just blocked in the middle where the requirements like aren't clear or product have changed them again, which, it sounds a bit cheesy, but we actually have a more ambitious product roadmap now because we proved that teams could work together even though they owned their services separately. This is genuinely powerful because if you can prove you can do that, you will be able to create a product ecosystem with teams collaborating to like one shared vision and one shared product and one shared external API, which was the big one for us. Engineer onboarding is a bit smoother now, and moving engineers between teams, the feedback on that is really good, whereas it used to be a big problem for us. Teams can open pull requests on other teams' services now, which was difficult before, but now it's quite easy, and that's a really, really powerful thing when you're working on these projects where teams have got to synchronize. And I already mentioned, like, you can invest centrally and roll things out to different services from a central investment much, much easier now. It's not all perfect, right? So I'm going to talk about some of the disadvantages. You are having some kind of central decision-making. When you make decisions about how servers should look or how observability should work and instrumentation should work across all teams, those decisions are going to take you much, much longer, and you're going to have big debates. But the idea is that you will save lots of little debates in those teams way later on. And so it's worth it. We do a couple of things to make that process a bit easier. We use decision records. People might call them ADRs or RFCs. We're fairly new to that, but we feel that writing down and getting stakeholders and sign off on those decisions really helps us be a bit more rigorous in our decisions and prove that they're kind of the right thing to do. We're creating a bit of work for teams, making sure they're up to date on the latest libraries. We do try and avoid breaking changes, but they do happen sometimes, and that can be really annoying. And you can use tools like our dependency tree and Rody to help you with that. But at the end of the day, our AppEx team, quite a lot of the time, have to go in and upgrade services themselves, which is painful. And that's not ideal. And of course, when you come up with new standards, one new standard to unify everything, what you've done is you just created a new standard, and that makes you even more diverse, which is not what we want. So we're not 100% consistent, and we're not pretending we are, but we now want to get there. The most important thing is that our culture now values that, and we're going in the right direction and unifying rather than getting more diverse. You can't do it everywhere, though, even then. Postgres can't do everything, right? So we've got services using OpenSearch. Maybe you've got vector databases in some places. Very cool. But most of what those services do probably is shared with the rest of your system. There's real costs of this, by the way. So, to be honest, if you're doing top-down, if you're just saying services must conform to this, APIs must be designed in this way, that is quite a cheap thing to do, but you have to have a culture that accepts that. You have to have a way of working where teams enjoy that and are happy to do it. It's much easier to provide that consistency through a golden path and have teams follow it, right? But that's really expensive. So building out your own toolkit like we did is expensive. We are lucky to be able to do that. We were at the scale where that made sense for us. It might not be for you. So yeah, you've got to keep an eye on whether you think you can have that impact. A good one, though, is open source or even commercial toolkits. You don't have to build one yourself. We did because we thought we had very specific things to Paddle to deal with some of our legacy systems, to deal with the new product ideas we had, that we wanted to build that ourselves. There's some really cool community ecosystems out there, right? gRPC, that's kind of just server and client, and there's lots more to our toolkit, but a good place to start. We like Humor as well. If you like building more REST and JSON APIs, Humor is very cool. Encore, I didn't go to the big tutorial about Encore yesterday, but that project looks extremely exciting and is very, very close to my ideal model for how it should work. So engineers, though, we want to try stuff. We want to try stuff. But you've got to ask yourself, when is the best place to do that? Diversity in your technical implementations creates a crazy amount of complexity, cost, and risk, right? So, prototypes, hackathons, proof of concept ideas. We love doing hackathons at Paddle. We should do more of them. We only do one about once a year, but it's a fantastic way to introduce new ideas into the company and prove things out. This is kind of controversial, but we want to avoid CV-driven development, right? A lot of the time we want to introduce new tech because we're maybe a bit bored. So double check that. Really, I think what engineers want is to be engaged and to own stuff and own technical decisions. So our approach really there is making technical decisions that are sound and that will give us a good platform and empower engineers that way, rather than kind of letting people introduce new programming languages that introduce new costs. There are unique decisions, though. There's still opportunities to use technology. You just have to be disciplined and make sure that it is actually needed to go against the grain in that particular case. We do want to learn new skills, right? Engineers do need to be able to do that. And I'm not saying that shouldn't be a thing that engineers should do and you should stick to this for the rest of your life. I'm just asking everyone to be disciplined about it. So here's a few recommendations. Microservices, they're great, right? They do allow independence. They do allow teams to work in parallel, but be careful of those risks. Make it really boring to add a new service, and you'll avoid those risks. You do need strict standards if you want to have a great external API, for example, or a great internal API. But you've got to make it easy for teams to follow it. If you're going to create a platform team or an AppEx team, make sure they're not making armchair astronaut architecture decisions. So make the strategy transparent, explain why you want this, get that feedback from engineers, and accept that not everyone's going to be on board, right? It's a really difficult job to go and try and get everyone to be consistent. The soft skills will help you. It's not just about creating the best libraries. To decide what to standardize, what to learn from us is look at what decisions are being made in those teams. Don't look at the code they maybe have today. Look at what are people deciding and debating. Look at what those systems have in common, of course, and have a look about what they're going to be building next. Most of the value we found came from standardizing where those systems talk to each other. That's probably the best inroad, where you can have the biggest impact. And it's got to be really high quality to get that trust. It's really difficult to do. I think we achieved it, but in some cases, we tried to roll out libraries that didn't make it, and it very quickly becomes apparent that teams don't want to use that. So lean on open source, lean on community where you can. You can learn a lot from there. But of course, I'll leave you with this, right? If you don't have that trust and respect between individuals, none of this is going to work. No brilliant toolkit and framework is going to solve all of your engineering problems. So great teams of great people, always more valuable. And that is the story. And now we're going to do some Q&A, and I'll try my best to answer it. We have a couple of blog posts about some of the product things we've built. There's one about payment routing, which is what my team work on. There's one about our developer API and developer docs and how we put that together, which is pretty interesting as well. So feel free to check that out.
Fantastic. First question.
Thank you very much. I work at a company that has similar internal libraries that we've developed, which are basically going to seed. There isn't a lot of defense of the. There's no one assigned to maintain those libraries at the moment. It's a cost that doesn't seem to be directly connectable to customer outcomes, and so no investment there. How do you protect the investment in your application excellence teams?
Yeah, it's a really good question, especially when you've got competing ecosystems. Is that right? You've got different language ecosystems, or is it just one?
It's just one.
Okay. Yeah, I mean, I think you have to demonstrate the value somewhere. And my style of doing that is to, instead of saying how wonderful and productive would all be if we invested in this, is to show the harm being done when it falls apart. So we have to be really make the maintenance cost really obvious. I think that's one of the things we saw here, was that we had to make the cost of all this complexity really obvious and try and point at places where you've got, firstly, those external harms of well, we haven't invested in this and it's led to bugs, or it's led to slow delivery. Well, sorry, that's more an internal one. External one, like reliability and bugs, or poor API design that's frustrating customers, let's say. And then point at those harms that are more internal, right? Like, we're not shipping right, these teams are arguing about this. It's a very hard problem, right? You need a champion at exec level who gets this stuff and who understands what those harms are and has lived it. And that can be really difficult.
Thank you.
Not sure what else I can help with.
Next question.
Any techie ones? We can go back to the code examples and talk about them if you want.
Yeah, first of all, thanks for the talk. I really enjoyed it. My question would be how you deal with teams actively leaving the golden path that you paved. So I really liked the dashboard that you had, showing all the scores, but are you actually approaching teams having a low score and try to push them to increase it, or what's the plan there?
I'm not, because I work in a product team, so I dodge that. Yes, I think we've been fairly lucky. We're fairly early on this journey, and people actually want to buy in, right? And we managed to achieve that, which I think is awesome. Yeah, it's difficult. I think it depends why they're making that decision, right? I think what we would do is go what's going on, try and understand the context. Is it because they have a really unique scenario, right? What we try and do is cover if we're doing something weird and new, or some new problem, building a new service, write a design document. We do them as decision records as well. So hopefully there's some understanding of why that decision's been made to go away from it. There's plenty of cases where people have they just haven't adopted the new one, but actively moving away, yeah, I think we probably need to get better at like spotting when that happens, and asking like, why are we doing this? That's probably something in our culture that needs to evolve a little bit, right? And I think management have to be part of that, going like, are your technical decisions sensible, and like how are we holding engineers accountable? Like, why are we wasting our time doing this? We don't, at the moment, we don't feel like our AppEx team and like Alec should be the one to kind of go and ask people that. We very much like this way where kind of he's laying that golden path, rather than chasing people up about those things. When it has happened, it's been like, we need to use a different database, or like we need to do this. We need to respond to webhooks in a way which our framework doesn't like responding in, right? Because it's not the main developer API, it's like a webhook. So usually you can sort of justify it and ask people why. Yeah.
Thank you.
Hi, thanks for the talk. Could you share some lessons that you've learned?
Sorry?
Could you share some lessons that you've learned with regards to versioning and breaking changes, especially when you are iterating through trying to get the API right?
Yeah, it's a nightmare, right?
Yeah.
So we started by accepting that we didn't want everyone to be using the library straight away. So the pattern we followed was to kind of have unstable versions at first that are only used in like one service or two services, so that by the time you've figured it out, you think you're at a stable version. That's the point where you say, actually, we think all teams should be using it. And then if the reaction's good, if people like it, then you probably want to keep it as stable as possible. I'm trying to think of examples, but in one case, we had a slightly older library that did sort of like database connection stuff, transaction orchestration, like an early attempt at that, which instead of doing a new version and trying to deal with that problem, we just said, here's a totally new one, and trying to get adoption of that instead, just because it's such a breaking change. But yeah, it's really hard. Yeah.
Thank you.
Next question.
Yeah, thank you for sharing this experience, because I think our company also have the similar stuff, but in Java version. So my question is, creating this kind of like standardized toolkit, it unifies your like internal services and also like improve, let's say, other teams building the service and push it to like production really quick. But I feel like it also generates some kind of like dependency, isn't it? So for example, if there's a bug in your toolkit and there were like 10 teams using this toolkit, and obviously it will kind of like produce or increase some dependency. If in that scenario, how could you deal with that? Or has it happened before?
Yes, bugs happen. I mean, yeah, it's an interesting one. Like, would it be a better situation if all those teams used all different libraries and solved the problem in a really different way, right? Because then maybe only one of the teams would have that bug that you'd then go and have to like patch. Maybe that's good. We think that actually getting deployments out and getting teams up to date is actually a solvable problem if you use things like Depend-A-Bot and you use some of the other tools. Because all the teams are managing their dependencies anyway, right? So if you lean on, like, you know, these are Go modules, we've got GitHub, we've got Depend-A-Bot, they're used to merging in dependencies, and there's no reason why every team wouldn't just act like it's a normal dependency upgrade with a bug that they need to fix. So we, at the moment anyway, we think the value of consistency is worth it with that particular, you know, dependency management and doing that, like pushing out those dependencies as like a problem we know we have to solve, basically.
Thank you.
Makes sense.
Yeah, makes sense. Yeah, it's more like a pros is more than cons. Thank you. I got a second question. So so this is more like internal toolkit. And for example, if you have a junior engineer on board, let's say in Paddle, probably not your team, how could you make sure these kind of like junior engineers can technically grow? Because maybe they're only familiar with the internal toolkit, but probably they're not familiar like more open source toolkit or web framework.
Yeah, I think that's a really good point. I hadn't considered the idea that like if you're doing your own thing and rolling your own everything, people who come from the Go community are used to something else already. They have to learn a whole new toolkit, and that's a pretty powerful argument not to do this and just to use like an open source thing. I still think you should be consistent everywhere, by the way, obviously. But that's quite a good idea, like to not do it in-house, maybe. The way we deal with that is we try and document things. Probably need to be better at that. But the service template is really, really good. The idea is it's not just a template where you have to go and edit everything. You can just run it. So you can toy around with it. You can add a new endpoint, see how that works, add some new tests, see how that works. And that service template has most of the libraries there that you can play with and have a look at. So that might be the sort of best way to do it, is like creating toy examples from that sort of thing. Yeah.
Thank you.
But we also run workshops like for new starters where we basically run you through the common things, why we build it like this, the main tools, and do some demos. So we have a kind of like structured onboarding session when you join as well to explain it more like this.
Okay, thank you. That sounds really good because I think, as you mentioned, like regular workshop or like a channel, like people can ask questions and have lots of learning materials. That would be great.
Yeah, we have like a Golang channel in Slack. The AppEx team as well, they're very helpful. Like you drop messages and ask things. They're around to consult for teams and help them solve their problems as well. No one's asked about open source yet, so I'm just going to address that. Like, there are some things in here which we think would be amazing contributions. We know what it takes to like run a really good open source project, and it's really, really hard, and really like we want to get it right. It's kind of like our dev docs example. We would love to do it. We think it's going to come maybe later this year, early next year. We just want to make sure that the investment is there to make that really work, because otherwise it will look really lame and it will be a flop. Another interesting topic is like so we have this Python org in Paddle as well, which I'll mention. Obviously, we're not trying to force them to use the Go toolkit. So those of you who work at larger orgs, you may have done things like acquire other companies, or maybe your company's been acquired. I think these are really good examples of where this consistency starts to break down and you have to absorb this maintenance cost. So what we do is, we try and standardize each ecosystem, right? It makes sense. So within the Python org, we'd be as consistent as possible. Within the Go org, we'd be as consistent as possible. But I think that is a particular challenge. So I'm not suggesting in a really big company that like everyone has to use this toolkit, because it's clearly just like not possible.
Okay. Should George choose to entertain us, we still have 7 more minutes or so. So next question.
Hi, thank you very much for the talk. I was just interested in what the structure is of the AppEx team. Like, how big is it, and does it have like its own team lead and sort of internal product manager?
That's the dream. That's the dream. Right, we don't quite have the budget for that. But it started as Dan, who's over there, as senior engineering manager at the time, but pretty hands-on at the time, I think. Alec as principal engineer, and we had a staff engineer as well. Scott, who was there yesterday, worked as staff engineer on that project for about 2 years. So between the 3 of them, that's basically they achieved almost all of this. But it's still 2 people, I think. Kranti is currently in the AppEx team. Go talk to Kranti. He's not here representing Paddle. He's just here as an attendee to learn, but I'm sure he'll answer some questions if you have any.
So that 3% investment?
Yeah, you mean out of the like 90 total people? Yeah, that 90 includes non-engineers like managers and stuff, but pretty much all technical. So yeah, I didn't want to add like a rule of thumb for at what point does the investment become worth it, because I think it depends on what your existing stack looks like, what your product ambition is, how much funding you've got from VCs, So I think it's, I'm not going to pretend to know a good rule for that. But for us, we think it made sense. It was successful for us, so we're going to continue investing in it. But there's a whole side of this, which is the infrastructure side as well. That had a huge transformation to make that more consistent. So that was a very deliberate investment as well. But our SRE team is currently only about 4 people as well.
Oh, actually, can I just add on to that? Yeah. So in terms of ownership, so suppose there is a change that needs to be made to the libraries, is that primarily with the AppEx team, or do developers feel confident enough just across the different teams?
Yeah, that's a great one. Alec always asks, he wants more contributions back. He really wants to engage everyone. But I think people are in their product problems, right? So it does tend to be from them mainly driving the changes and trying to get that feedback themselves to try and then put those changes. But yes, we welcome all those changes. And because people are very familiar with those libraries, we've contributed back. So my team actually we've contributed, even though we came from this gRPC ecosystem, we contributed back because we've adopted some of those libraries in our services, the ones that sort of fit. So even though we're using gRPC, like for maybe logging, observability, testing, we're now adopting them where we can, and we've added things to sort of help us out. We've also, the way we contribute to the toolkit isn't just all from AppEx. So I think the transactional outbox component actually was originally built, Akash, he built it, in the payments team originally, and that was kind of adopted and made more generic for all of our services. We made it agnostic between MySQL and Postgres and SNS and EventBridge. So we are actually like, if a team has a unique problem and they're jumping on it, we'll be like, maybe another team is going to need that pretty soon, and then we'll like absorb that and try and invest in it and support it and sort of take it off the hands of the product team, if that makes sense.
Thank you.
Next question.
First of all, thank you very much. I really enjoyed that talk. Just following on from like the business sort of buy-in question for all of this, were you able to develop any kind of like concrete metrics to say this is definitely working? Not to like, I don't want to say like prove, that implies like a lack of trust, but kind of have like more confidence that this is the right thing to do? Yeah.
Measuring engineering organizations is really hard, right? And we are not good enough at it, I'm just going to be honest, and we're getting better at it. We do have some metrics. I deliberately didn't show them because I'm not sort of confident enough in them to tell you guys that those are the metrics you should look at. I think also like we didn't measure anything when this whole stuff started. And so it's very difficult to have a sort of comparison like that. But the things we do look at are getting feedback from engineers is really important. Like, how productive do you feel? How much toil did you have today, right? And that's really important to us. We kind of look at DORA type stuff, like how much a team's deploying, do pull requests, how long a pull request taking, how active is everyone in the team, like number of deployments, like adjusted by size of team and that kind of thing. It's a difficult one because fundamentally what we're trying to do is create more value for the company in like this with the same amount of like cost in terms of effort. But we hardly ever solve the same problem twice, so it's very difficult to like compare. Oh, it was easier this time because we used the toolkit. Because story points aren't going to tell you that, right? Like, the number of developer hours isn't going to tell you that. So I like that you picked me up on that, but I'm very aware that I wasn't able to give like really solid metrics because we're just not there yet, basically. Yeah.
Thank you very much.
Okay, we might be able to do one last question if one exists. Okay, with that, fielding all of those, I reckon you'd have made Alec proud. So well done, George. Big hand, everyone.
Thanks, everyone.
George Wilson.